Hello, class. This is Mr. Eggleston, and I'm continuing working out some of the problems for your Algebra 2 spring semester final. I left off on problem 17 of the review. I'm doing problem 19, then 21, 22, 26, 27, 29, and 34, 36. So I got quite a bit, 38. I got half of the problems I circled done. So going back up here and starting with 19, as before, we have to factor. So looking at 40 and 16, I know a 4 can be pulled out. Actually, better yet, an 8 can be n squared can be pulled out, which would leave us with a 5n minus 2 on top. On bottom, that would be n minus 7, n minus 2. All right. On this top is n minus 7 and n minus 2, which is the same. In other words, I could have just done this, and those would divide out. And then this 20n minus 8, you could pull out a 4. That'll be n. Oh, excuse me, not n. It'll be 5n minus 2. Notice there's a 5n minus 2 on top over here. Divides out with the 5n minus 2 over there. Yep, I already said this, but those are gone. And it leaves us with 8n squared over 4, which can be reduced to 2n squared. All right, there you go. That was 19, which wasn't circled, but I guess I just wanted to do it, I guess. Okay, 21. Let me make sure that I'm not skipping. Yep, 21 knows that's division. So we still factor everything. 2x plus 10. Oh. 2x plus 10. Like that. We got x minus 3. This one is x minus 7, x plus 3. And this one down here is x minus 3, x plus 3. And then you see the x minus 3. Oh, you know what? Before I do that, this is division. Flip right, multiply. So let me write down the factored form here. We got 2x plus 10 over x minus 3 times, now this gets flipped upside down right here. This gets refliplicated. And so I'll just write it out as x minus 3, x plus 3 on top, and on bottom is x minus 7 and x plus 3. Looking at this, the x plus 3 divides out because they're on top of each other, and the x minus 3 leaves us with a 2x plus 10 over x minus 7 as the simplified rational expression for 21. All right, so again, division, you turn into multiplication by flipping the right fraction upside down to find the reciprocal, and then we multiply, because that's how you divide fractions. You multiply by the reciprocal. All right, and 22, factor everything. This is division again, so this would be 6n minus 2. This one up here would be n, what's that, negative 20, so that'd be negative, or positive 10, negative 2. All right. And then this one right here is the same thing. N plus 10, n minus 2. We reciprocate everything. All right. turn it into multiplication, and then this stays the same, and it's n plus 10, n minus 2 over n minus 2. Notice, again, these both divide out. I could have seen this here if I remember that this thing gets flipped upside down. You're left with, oh, and the n minus 2's go away, and it looks like the answer is just 6. It's just this that's left over. Wow. Okay, and that was 22. Again, the trick was to turn division into multiplication by multiplying by the reciprocal. Okay, continuing on, 26. Now we're solving equations. Multiply everything, the easiest way is just multiply by the LCD of all the fractions. So the LCD is v minus 5 from here. You still got v minus 5, but you already have that, and there's just a 1 there. So we multiply everything by v minus 5. So our equation was 1 minus 1 over v minus 5 equals 4 over v minus 5. Now I'm just going to take the LCD of v minus 5, and I'm going to multiply each of these by v minus 5. Notice on each of them, like on these, the v minus 5's divide out, the v minus 5's divide out, and we have to figure out what this is, 1 times v minus 5, which is, drum roll please, I know this will blow your mind, v minus 5 minus 1 equals 4. So minus 5 minus 1 is minus 6. Add 6, you got v equals 10. All right. 10 does not make the LCD equal to 0, so that is a valid solution. Pretty straightforward, not that difficult. 27 gets a little hairy, just because we're dealing with polynomials that are going to have to be factored. So the first thing I'm going to do is factor all the denominators. So the first one would be, pull the 3 out, and it'll be 3n plus 1. The second fraction, pull the 3 out, you'll have this. And then the n squared minus 3n minus 4 can be factored as n minus 4, n plus 1 with the 3. So I'll just erase that and say that this is the factored form of that denominator. And then the last one looks like is just is basically the same thing as this, because without the 3. So this is going to be n minus 4 n plus 1. So I got all the denominators factored. The LCD is going to be, you see these terms, 3 times n plus 1, that's got to be part of it. Okay. On this fraction, we see a 3 and an n plus 1, but we are missing the n minus 4. So we have to add the n minus 4 to our LCD. Okay. And on the last fraction, the n minus 4 and n plus 1, we have both of those right here. So this is the LCD. So I'm going to multiply the LCD, this thing, against each fraction and write out what we get. So if you look at this, 3n plus 1, 3 times n plus 1 times n minus 4, divide by 3n plus 1. The 3n plus 1's divide out, leave you with an n minus 4. So this is going to be 1 times n minus 4. Minus. Now, this is the LCD. So that's just going to, everything divides out, and that leaves you with a 1. Okay? And that equals, okay, we have our 5. Now, if you look at this, this is a 3 n plus 1, n minus 4. This is n minus 4, n plus 1. Those go away, leave you with the 3. So this is 5 times 3. And we have this rather straightforward equation to solve. So let's looking at this. 1 times n minus 4 is just n minus 4. Minus 1 is n minus 5 equals 15. 5 times 3. Add 5n equals 20. The last thing we should do is check to make sure that 20 does not make our LCD equal to 0, and it doesn't, so n equals 20 is the solution. All right, now let's jump down and do 29. Same idea, factor everything. So I'm looking at x squared minus 4x minus 5, or k squared, so that would be k minus 5, k plus 1. Okay, that's k plus 1. Doesn't need to be factored. This is the same thing as that, so this is k minus 5, k plus 1. So our LCD looks to be k minus 5, k plus 1. So the LCD is just the k, I wrote x like a silly boy. K minus 5, k plus 1. So we're multiplying each of these fractions by that. And when we do that, you'll see things divide out, like k minus 5, k plus 1 divides out with the k minus 5, k plus 1. In other words, this goes away when we multiply by that, leaves us with the 2. Minus, or no, that's equals. Now the k plus 1 divides out with that k plus 1, leaves you with the k minus 5, so that would be 1 times k minus 5 minus, now this is the complete LCD, so the whole thing goes away, minus 1. So we have this simple linear equation. So we got 2 equals, let's see, 1 times k minus 5, it's just k minus 5, minus 1 is k minus 6. Add 6, you got k equals 8. Let's check to see if k equal to 8 gives you a LCD that's 0. We're looking at our LCD, k minus 5, k plus 1. 8 does not make either one 0, so that's the solution. You can't really read it. Nope. Okay. Moving on. Now we're going to the trig, the stuff that we've been doing at the end. It says find the value of all 3 trig functions, sine, cosine, tan, of the given angle. Leave your answer in reduced fraction form. So notice on 34, you have 10 and 8. So we're missing the final side. So we got to figure out what this side is. Easiest way to do it is Pythagorean. Let me just write this down. You should know this. A squared plus b squared equals c squared. So you would say, I'll call this x. X squared plus find the values of all 3 trig functions. So we have to find the hypotenuse, or find all sides. So it'll be x squared plus 8 squared equals 10 squared. X squared equals 100 minus 64, which is 36. X equals 6. So we know this side is 6. So now, sine of theta, remember we have to always pay attention to where our theta is. It's right here. Sine is opposite over hypotenuse, so this is going to equal 6 over 10, which reduces to 3 over 5. Cosine of theta is going to be adjacent 8 over 10, which reduces to 4/5. And tan theta is going to be the ratio of the sides, the opposite over adjacent, so that would be 6 over 8, which reduces to 3/4. And there you go. All right, that's how you do that. 36 is the same thing. You got to find the missing side using Pythagorean. So we got to find this x. So you know that 7 squared plus x squared equals 25 squared. X squared equals 25 squared minus 7 squared. And 25 squared minus 7 squared is 25 squared minus 7 squared, which is 49, is 576. I know that's a perfect square. So x equals the square root of 576. So we go square root of 576 is 24. All that to get this side to be 24. Notice this side is only 1 unit longer than the hypotenuse. So now that we have all the sides, you just do the ratios. Sine is going to equal theta's here, so opposite over hypotenuse is equal to 24 over 25, which is almost 1. Cosine is adjacent over hypotenuse, so that's going to be 7 over 25. Tan is opposite over adjacent, and that's 24 over 7. All right? So, and that's how you do that. It's not that bad. All right. Now, solve each triangle, round the answers to the nearest tenth. Notice on 38, we have 2 of the sides. We can use Pythagorean to find the third side. That's what it means. We have to find all the sides and all the interior angles. That's what it means to solve. So we're going to go 9 squared plus 10 squared equals x squared, where this is x, the hypotenuse. So 9 squared plus 10 squared, which is 181. Okay, and we're going to take the square root. Okay, so x equals the square root of 181. Now, I don't think 181 is a perfect square. We can try. Yeah, it's not. So we're just going to have to leave it as the square root of 181. Do not write it as a decimal. Leave it in exact mode version, which is the square root of 181. So we got the sides. Now we have to figure out the angles. Excuse me. So for angle B, I like to use inverse tan. So tan B is going to equal opposite 10 over 9. So B equals tan inverse of 10 over 9, making sure that your calculator's in degree mode. So I'm going to go ahead and do it on the screen so you can see it. Every time I open this up, I know for a fact my calculator is in radian mode. So the first thing I'm going to do is switch it over to degree. Okay, now it's in degree mode. And it was, I believe, 10 over 9. It is. So I'm going to go, second tan. That's how I get second tan inverse of 10 divide 9. Okay. Enter. And that is 48 degrees. So B equals 48 degrees. If B is 48 degrees, we can get A easily. A is going to be 90 minus 48. All right? So 90 minus 48 is 42. So angle A equals 42 degrees. So here's one answer. Here's the other, and we got all the sides. We solved the triangle, which means we found all the sides and all the angles. Okay, pretty straightforward. Try to use tan inverse. Tan, I like tan. When you have to use sine or cosine, you always have to know what the hypotenuse is. Now, like on 40, where they give you the hypotenuse, to find the other sides, first thing you should do is realize that angle B is just going to be 90 minus 27. So the measure of angle B equals 90 minus 27. Because remember, the sum of the interior angles of any triangle is 180, and if one of the angles is known to be 90, that means the other two angles have to be 90. So I'm doing 90 minus 27 gives me 63. So we know this is 63 degrees. Now that I got that, I can figure out the sides. I can use sine of 27 equals, I'll just label this x, will equal x over 10.4, or x equals 10.4 times sine of 27. So I'm focused on this angle. Okay. I'm sorry, so that's, oh yeah. So I'm focused on this angle. So I'm using sine, which is opposite x over hypotenuse. I just multiply both sides by 10.4 to get x by itself. And so I just have to evaluate what 10.4 times sine of 27 is. On my handy dandy calculator that's in degree mode, it says it's 4.7. So we know the measure of BC is 4.7. All right. Now you got a couple options. You could find the measure of the length of CA, which I'll call y, by Pythagorean, saying 4.7 squared plus y squared equals 10.4 squared, or you could just say I use sine to get opposite over hypotenuse. I can go cosine, which is what I'm going to do. I'm going to say cosine of 27 is adjacent, which is y over 10.4. So y equals 10.4 times cosine of 27 degrees. And then again, you use your calculadora. So that's 10.4 times cosine of 27. This comes out to be 9.3. So y equals 9.3, x equals 4.7. And you solved the triangle. You found all the missing pieces. All right? That was 40. 42 says find the measure of each side indicated. So round to the nearest tenth. They want you to figure out what x is, given the fact you know the hypotenuse and this angle here. This angle is opposite the thing we're looking for. So I'm going to, and they gave us the hypotenuse. So I'm going to use sine. I'm going to say sine of 38 degrees, again, I'm focused right there, is equal to x, which is the opposite side, over 10.1. So x equals 10.1 times sine of 38 degrees. Again, going to your calculator, you get 10.1 times sine of 38. And I got 6.2. So that's the missing side. All right. This is very much like the ones above where it says resolve the whole triangle. Except for this is easier because you only need to find one thing. Moving on. And that looks to be it. Looks like I did all the problems. I hope that was helpful. All right? I really do. I hope you have a wonderful evening and study hard. Bye-bye.